There's a moment that stops every historian cold. You're standing in a museum. Behind the glass, a photograph, maybe 100 years old, a Comanche warrior. And something about his face makes you pause. You expected something, some image you'd seen 1,000 times, from movies, from old paintings, from every Western ever made. But what you're actually looking at doesn't match any of it. The cheekbones are different. The build is different. The eyes carry something that no Hollywood casting director ever thought to put on screen. And then someone tells you, scientists just finished reading the DNA of people who lived on this land 3,000 years before the Comanche ever arrived. And what they found? It rewrites everything, not just Comanche history, not just Native American history. The entire story of who came to this continent, when they came, and how the people we think we know actually became who they are, all of it is being rewritten right now, in laboratories, from fragments of ancient bone. That's what this video is about. Let's start at the beginning, and I mean the real beginning. For most of the 20th century, there was one story about how humans first arrived in the Americas. It was clean. It was simple. It was taught in every school. Ice Age, a land bridge, Siberia to Alaska, hunters following mammoths. They spread south. They become the ancestors of every Native American people on the continent. Done. Case closed. Except it was never that simple. And the Comanche, of all peoples, are where that story starts to crack open. Here's what most people think they know about the Comanche. They were the greatest horse warriors in the history of North America. That part is absolutely true. At their peak, the Comanche controlled a territory larger than most European countries. They raided deep into Mexico. They held the Spanish, then the Mexicans, then the early Americans at a standstill for over a century. Historians called their territory Comancheria. It covered what is now West Texas, eastern New Mexico, southeastern Colorado, southwestern Kansas, and western Oklahoma. An empire built on horseback. They acquired horses in the late 1600s, sometime around 1680, and within one generation, they became the most dominant military force on the southern plains. The transformation was astonishing. A people who had been mountain foragers in what is now Wyoming and Idaho became, within decades, the undisputed lords of the open grassland. How does that happen? How does a people transform so completely, so fast? The conventional answer was always adaptation, opportunity. Horses changed everything, and the Comanche seized that opportunity better than anyone else. But ancient DNA is now asking a different question. Who were the Comanche before the horses? And where did they actually come from? The Comanche speak a language called Numic. It belongs to the Uto-Aztecan language family, a vast web of related languages that stretches from Idaho all the way down to Central America. Nahuatl, the language of the Aztecs, is in this same family. The language of the Hopi, the language of the Shoshone. The Comanche and the Shoshone are, linguistically, almost the same people. They split somewhere around 1,300 to 1,400 years ago. Before that split, they were one, so the Comanche didn't arrive from nowhere. They came from the Great Basin, from the high desert country of what is now Nevada and Utah. They were foragers. They dug roots. They hunted small game. They moved in small family bands across some of the harshest terrain in North America. And before the Numic peoples spread across the Great Basin, before that, that's where it gets interesting. That's where the DNA starts talking. The Great Basin, for most of human history, was not Numic country. Before approximately 1,000 years ago, which in archaeological terms is practically yesterday, the Great Basin was home to a completely different population. We don't know what language they spoke. We don't know what they called themselves. We know them only through their archaeology and now through their bones. Archaeologists call them the Fremont culture. They were farmers partly. They built structures. They left behind art, carved into rock faces across Utah and Nevada. That looks nothing like later Native American traditions in the region. And then, around 900 to 1,000 years ago, they vanished. The Numic expansion, the spread of Shoshonean and Comanche ancestors across the Great Basin, appears to have happened at almost exactly this moment. Whether the Fremont were absorbed, displaced, or simply left is still debated. But here's what ancient DNA is now revealing. The people who lived in the Great Basin before the Numic expansion were genetically distinct from the people who replaced them. Measurably, clearly distinct. Meaning, what we call Native American is not one ancient population that simply spread and diversified over time. It's the result of multiple waves, multiple replacements, multiple populations meeting, and sometimes one erasing the other. Sound familiar? It should, because the same pattern is showing up everywhere scientists look. Now let's zoom out even further, because to understand the Comanche, you have to understand where all Native Americans came from. And that story is far stranger than anyone expected. The old model, Siberia, land bridge, done, is not wrong exactly, but it is massively incomplete. Ancient DNA studies published in the last 10 years have revealed that the first Americans were not one population. The earliest people to arrive in the Americas, somewhere between 15,000 and 20,000 years ago, were themselves already a mixture of at least two distinct ancestral groups. One group is related to ancient East Asians. The other, and this is the part that shook the scientific world, is related to populations from what is now Australia and Papua New Guinea. An ancestry signal from the other side of the planet, showing up in the DNA of people who lived in the Amazon basin and in certain ancient remains from North America. How? The honest answer is, we don't fully know yet. There may have been a second, earlier migration that took a coastal route along the Pacific. There may have been populations moving through Southeast Asia and along coastlines in ways we haven't yet traced. What we know is that the first Americans were already complex, already mixed, already carrying the genetic fingerprints of a journey that started deeper in the past than we imagined. Here's the thing nobody tells you in the standard history. The Americas were not empty waiting rooms. They were not a blank canvas. Before the Comanche, before the Shoshone, before any of the peoples we can name, the continents were occupied by populations that left almost no cultural trace because they were replaced so thoroughly. The Comanche are not the beginning of the story. They are, like all of us, somewhere in the middle of it. And ancient DNA is finally letting us read the chapters that came before. So what did the DNA actually find? What do the bones say? In the next part, we go into the laboratory. We look at the specific studies, the sites, the samples, the genetic signatures that have forced historians and geneticists to completely rebuild their model of who the Comanche are, where they came from, and what their rise to power actually means in the context of a much, much older story. Because the Comanche didn't just appear on the southern plains. They arrived there at the end of a genetic journey that started tens of thousands of years before the first horse was ever tamed. And some of what that journey reveals, about who was on the plains before them and what happened to those people, is the kind of thing that changes how you see not just one people, but the entire human story of this continent. Stay with me. Let's talk about what ancient DNA actually is. Because this isn't magic, this isn't guesswork. This is science that has been refined over 30 years to the point where researchers can take a fragment of bone, a tooth, a piece of skull, sometimes nothing bigger than your thumbnail, and read from it a story that no document, no oral tradition, no artifact could ever tell. Here's how it works. In simple terms, when a person dies and is buried, their DNA begins to degrade. Bacteria eat it, water breaks it down, heat destroys it. In most conditions, after about 1,000 years, there's nothing left to read. But in certain conditions, cold, dry, low oxygen, DNA can survive for tens of thousands of years. The oldest human DNA ever successfully sequenced came from bones found in Siberian permafrost. Those bones were over 45,000 years old. The Americas, being warmer and wetter than Siberia, are harder. Samples degrade faster. For a long time, scientists couldn't get clean reads from ancient American remains at all. That changed in the last decade. New extraction techniques, new sequencing technology, new computational methods for filtering out contamination, all of it improved simultaneously. And suddenly, ancient North American DNA became readable. The results started coming in around 2015, and they haven't stopped. The first major shock came not from Comanche territory, but from somewhere much older. In 2018, a team of researchers published findings on a set of remains from what is now Alaska. The site is called Upward Sun River. The remains belong to an infant girl who died approximately 11,500 years ago. She was given a name by the researchers, Zakite Anen Taida Gai. In the local Athabascan language, it means sunrise girl child. Her DNA told a story that nobody expected. She belonged to a population that scientists had never seen before, genetically distinct from any known living group, distinct from ancient Siberians, distinct from the earliest populations identified in South America. They called this population ancient Beringians. They appear to represent the descendants of the very first people to arrive in the Americas, a founding population that crossed from Siberia into what is now Alaska somewhere between 15,000 and 20,000 years ago, then got cut off from Asia as the land bridge disappeared beneath rising seas. Most of them eventually disappeared, absorbed into other populations, replaced. But their genetic signature, faint, fragmentary, has been detected in some Native American populations even today. A ghost of the very first Americans, still faintly visible in the DNA of their descendants. Now let's move south, let's move forward in time, let's get closer to the Comanche. The southern plains, Texas, Oklahoma, Kansas, were not empty before the Comanche arrived. Far from it. For thousands of years before the Comanche expansion, the southern plains were home to cultures we know primarily through archaeology. The Folsom people, the Clovis people. Later, the ceramic period cultures. These were not simple hunter-gatherers stumbling around in the dark. They were sophisticated, mobile, deeply adapted to one of the most demanding environments on the continent. Clovis, the culture associated with the beautifully crafted stone spear points found across North America, dates to approximately 13,000 years ago. For decades, Clovis was considered the oldest confirmed human presence in the Americas. Then that model collapsed. Sites in Chile, in Brazil, in Texas itself, all showed human occupation predating Clovis by 2,000 to 4,000 years. The Buttermilk Creek complex in central Texas produced artifacts dating to approximately 15,500 years ago. Before Clovis, before the land bridge was even fully open. How did people get to Texas 15,000 years ago? The inland route was blocked by ice sheets. The only viable path was along the Pacific coast, boats, or walking along coastlines that are now underwater. And the DNA from these pre-Clovis populations? Where it has been recovered, it doesn't always match what came after. Meaning, the people who left those earliest traces were not necessarily the direct ancestors of later cultures. They may have been replaced too. Replacement, it turns out, is a recurring theme in American prehistory, a pattern that repeats again and again. Now we get to the critical question: who was on the southern plains immediately before the Comanche arrived? The answer is several peoples. Most significantly, the ancestors of the Wichita, the Caddo, and a group archaeologists call the Antelope Creek culture, a farming people who built Pueblo-style structures in the Texas Panhandle around 700 to 500 years ago. And there were the Apache. The Apache arrived on the southern plains before the Comanche. They were already there, already dominant, when the Comanche made their move south in the early 1700s. Here's what's genetically fascinating about the Apache. The Apache speak an Athabascan language, the same language family as peoples in Alaska and northwestern Canada, and ancient DNA confirms what linguistics suggested. Athabascan-speaking peoples migrated south from the subarctic relatively recently, within the last 1,000 to 2,000 years, meaning the Apache themselves were relative newcomers to the plains. They had displaced or absorbed earlier populations. And then the Comanche displaced them, layer upon layer, wave upon wave. The southern plains, which we tend to imagine as a stable homeland for specific peoples, was actually one of the most dynamically contested spaces in all of North American prehistory. So what does the DNA say specifically about the Comanche? The most important study to date was published in 2021 as part of a broader analysis of ancient and modern genomes from across the Americas. Researchers looked at hundreds of ancient samples alongside modern DNA from living members of multiple Native American nations. What they found in the Genomics-speaking peoples, the group that includes both the Shoshone and the Comanche, confirmed the linguistic evidence and went further. The Numic expansion across the Great Basin and onto the plains was genetically visible. It showed up as a distinctive ancestry component that spread rapidly from a relatively small founding population in what is now Southern California or the Southern Great Basin approximately 1,000 years ago. Before this expansion, the Great Basin was occupied by genetically distinct people. People with an ancestry profile that was older, more isolated, more connected to the earliest wave of Americans. After the Numic expansion, those people are essentially gone. Not dead, necessarily, absorbed probably, but genetically swamped by the incoming wave. The Comanche carry, in their DNA, the record of this replacement. They are both the replacers and the replaced, inheritors of something that was taken, which itself had been taken from something older still. But here is where it gets deeper than history. When researchers looked at the full ancestry profile of Numic peoples, and by extension of the Comanche, they found the same three-layer structure that keeps appearing across Native American genomics. Layer 1, the ancient base population, descended from the very earliest Americans, hunter-gatherers who spread across the continent more than 12,000 years ago. Layer 2, a later migration from Asia, roughly 5,000 to 8,000 years ago. A second wave, genetically distinct from the first, that spread into the Americas and partially replaced or blended with the earlier population in some regions. Layer 3, the Paleo-Eskimo or Nardine signal. A third wave, ancestral to Arctic and subarctic peoples, which pushed south into the continent within the last few thousand years. The Comanche sit at a specific point in this three-dimensional genetic space. Their profile reflects the particular history of the Great Basin, the specific mixing events, the specific replacements, the specific geographic isolation of the Numic ancestors before their explosive expansion. Every Comanche person alive today carries this entire history in their cells, 12,000 years of it, more. And then something happened that the DNA captures with startling clarity. Contact, European contact. The genomic signal of the post-contact period is brutal in its clarity. In population after population across the Americas, the ancient DNA record shows a genetic bottleneck so severe that it is almost without parallel in human history. The population collapse of the Americas after 1492 was the largest demographic catastrophe ever recorded. Estimates vary, but the most careful modern scholarship suggests that somewhere between 50 and 90% of the pre-contact population died within 150 years of European arrival, mostly from disease. Smallpox, measles, influenza, diseases that the indigenous peoples of the Americas had no immunity to. When 90% of a population dies, the genetic diversity of the survivors collapses. Rare gene variants become common variants disappear. Modern Native American DNA carries the scar of this catastrophe. Scientists can see it, they can date it, they can measure its magnitude. And here is what makes the Comanche story unique within this catastrophe. The Comanche, because of their military power, their geographic position, and their horses, survived the first wave of European contact better than most. They held their territory. Their DNA shows a bottleneck, but a later one, a sharper one, concentrated in the 1800s, when the buffalo were destroyed and the reservation system was imposed. The genomic record of the Comanche tells a story of remarkable resilience, followed by devastating collapse. 12,000 years of genetic continuity, expansion, and adaptation, and then, within 2 generations, a forced transformation that left marks still readable in the DNA of Comanche people today. This is where the science stops being about the past and starts being about right now. Because these findings are not just academic. They change how we understand what indigenous peoples are, what they carry, and what was taken from them. Not just land, not just culture. Something written into the biology of their descendants. Let me ask you something. When you picture a Comanche warrior, and I mean really picture one, not the Hollywood version, what do you see? Most people, if they're honest, will describe something assembled from 100 westerns and a dozen history textbooks. A composite image built from other people's imaginations. But the people who actually met the Comanche, the Spanish missionaries, the Mexican ranchers, the early American explorers and soldiers, left written descriptions that are surprisingly specific, and those descriptions don't always match each other. Some described warriors who looked exactly as you'd expect. Others described something that confused them, men with features they couldn't easily categorize. One Spanish document from the 1700s, written by a Franciscan friar who had spent years in territory bordering Comanche, described meeting a group of Comanche leaders and being struck by how different they looked from each other. Same people, same nation, clearly related, but physically varied in ways that surprised him. He didn't have the language to explain what he was seeing. He didn't have the science. We do now. Here's what the DNA is actually revealing about Comanche physical characteristics. The physical appearance of any population is written in a surprisingly small portion of the genome. Maybe a few dozen genes that control the most visible traits: skin tone, eye shape, face structure, hair texture. Out of 3 billion base pairs in the human genome, the ones that determine what you look like in the mirror are a tiny fraction. But those genes carry history. They tell you where a population's ancestors came from, how isolated they were, what other populations they mixed with. And when scientists looked at those specific genes in ancient Great Basin populations, the ancestors of the Numic peoples, they found something that forced a rethink. The earliest Great Basin populations show genetic signatures associated with the very first Americans, people whose physical features, as best as can be reconstructed from skeletal remains and genetic prediction, were not identical to what we associate with later Native American populations in the region. There was more variation, more range, a physical diversity that reflects the fact that these early populations were themselves the product of multiple ancestral streams. Let me make this concrete. Let's talk about one specific gene, EDAR. It's a gene that affects multiple physical traits simultaneously: hair thickness, tooth shape, sweat gland density, and certain aspects of facial structure. A specific variant of this gene, called EDARV370A, is extremely common in East Asian and Native American populations and is almost absent everywhere else on Earth. This variant appears to have been strongly selected for in ancestral populations in northeastern Asia, probably around 30,000 years ago. It spread with the migration into the Americas. But the frequency of this variant is not uniform across Native American populations. Some of the oldest remains show lower frequencies than later populations, meaning, as newer waves of migration came in from Asia, they brought higher concentrations of this gene and spread it through the existing population. The Comanche ancestors carry their own specific frequency of this variant, a frequency shaped by thousands of years of isolation in the basin, then rapid expansion, then the mixing events of the plains. When you see a Comanche person today, you are seeing the result of all of those forces acting on a small set of genes over thousands of years. The face is a map. Most people just don't know how to read it. Now let's talk about something that historians got badly wrong for over a century. The Comanche, in most early American historical writing, were described as physically homogeneous. One type, one look. This was partly racism, the tendency of 19th century writers to flatten all indigenous peoples into interchangeable categories. But it was also genuine confusion, because the Comanche themselves didn't fit the categories that observers were trying to apply. The Comanche were not a single bloodline. They were a confederacy, a collection of bands that had merged over time from multiple distinct origins. The major Comanche bands, the Quahadi, the Noconi, the Penateca, the Yamparica, the Kotsoteca, and several others, had different histories, different geographic ranges, and different degrees of admixture with neighboring peoples. Quanah Parker himself is the most visible example of this complexity. His mother was Cynthia Ann Parker, a white woman captured by the Comanche as a child and raised within the nation. His father was Pater Nocona, a Quahadi war chief. Quanah grew up fully Comanche, led the last free Comanche resistance, and eventually became the principal chief of the entire Comanche nation. His face, famously photographed, widely reproduced, shows exactly the kind of complexity we're talking about. Features that observers in the 1800s described in contradictory ways. The DNA would say both observations were trying to describe something real, but neither had the framework to understand it. Here's the thing about genetic admixture that most people don't intuitively grasp. Mixing doesn't average out. Not neatly. Not predictably. When two populations with different genetic profiles mix, the results in individual people are not a smooth blend. They're a mosaic. Some individuals inherit more from one side, some inherit more from the other. Siblings can look dramatically different from each other. The Comanche were also, like all peoples with complex admixture histories, carrying this mosaic in ways that matter medically, not just historically. When the reservation period began, roughly from 1875 onward, Comanche people were suddenly exposed to a completely different disease environment, different food, different physical conditions. Their bodies, shaped by thousands of years of nomadic plains life, were catastrophically mismatched to the new reality. The rates of tuberculosis, of diabetes, of certain cancers in reservation-era Comanche populations were devastating. And modern genomics is starting to understand why. Because the genetic variants that were adaptive on the open plains became maladaptive in a sedentary, enclosed existence. The DNA doesn't just tell you where people came from. It tells you what happened to them. The Comanche at their peak, say 1840 to 1860, were physically exceptional by any standard of the era. Observers from every background consistently described Comanche warriors in terms that emphasized physical capability, endurance, and a kind of effortless control that seemed almost supernatural. Some of this was training. You put a child on a horse at age 3, and by age 15, they are something that a cavalry-trained European soldier simply cannot match. But some of it was genetic. The Comanche genome, shaped by thousands of years in the harsh Great Basin, and then by generations of the most physically demanding lifestyle on the continent, had been under intense selection pressure. Now, I want to give you something practical here. Something you can actually use right now, for free. If you have Native American ancestry, or if you're simply curious about your own deep ancestry, the most accessible starting point is the academic literature itself. The studies I've been referencing are all publicly available. You can find them on PubMed, on bioRxiv, on the websites of the journals that published them. The second free resource is the Native Biodata Consortium, a tribally governed organization building a genetic database specifically designed to serve indigenous communities. Their public resources explain, in accessible language, what ancient DNA studies mean for living people. Third, the work of researchers like David Reich at Harvard, Eske Willerslev at the University of Copenhagen, and Jennifer Raff at the University of Kansas, all of whom have published books and given public lectures that are free on YouTube. That's your free starting point. Read those papers. Watch those lectures. Build the foundation. But if you want to go deeper, if you want to understand not just the science, but how it applies to specific ancestral questions, how to interpret a consumer DNA test result in the light of ancient genomics, how to trace population-level history through your own genome, that requires a more structured approach. I've put together something that walks through exactly that process, step by step, using the same research frameworks the scientists use, but translated into language that doesn't require a PhD. The link is in the description. Check it out, but stay here, because what comes next is the part of this story that most documentaries never get to. Because we haven't talked yet about what the DNA found when researchers looked at the people the Comanche defeated, the peoples they replaced on the southern plains. What happened to them, genetically, demographically, culturally? Because some of those peoples didn't disappear. Not entirely. Their genetic signature survived. In unexpected places, in unexpected people. And when scientists found it, the answer changed the entire story of who the Comanche were and what their rise actually meant. There's a question that serious historians have avoided for a long time. Not because they didn't know it existed, but because the honest answer was uncomfortable. The question is this: when a dominant military power sweeps across a territory and displaces the people who lived there, what actually happens to those people? The comfortable answer is, they moved, they adapted, they survived somewhere else. The honest answer, the one the DNA is now forcing into the open, is more complicated. Sometimes they moved, sometimes they were absorbed, and sometimes they effectively ceased to exist as a distinct population. This is what the archaeological record, combined with ancient DNA, is now showing about the southern plains in the period from roughly 1400 to 1700. Let's start with the people who were there before. The southern plains, in the centuries immediately before European contact, was a mosaic. Different groups occupied different ecological niches: river valleys, upland grasslands, the broken country of the Texas Hill Country to the south. The most archaeologically visible of these cultures are the ones that left the most durable remains: stone structures, ceramic traditions, specialized bison hunting technologies that required coordination and planning on a scale that implies significant social organization. The Antelope Creek people built multi-room stone structures in the Texas Panhandle. They traded with Pueblo peoples to the west. Their sites, when excavated, show a population that was settled in a way that later plains cultures were not. And then, somewhere around 600 years ago, before the Comanche, before the Apache, before European contact, they disappear from the archaeological record, not gradually, fairly abruptly. Their sites are abandoned. The distinctive pottery stops appearing. The stone structures are left empty. Where did they go? For most of the 20th century, archaeologists assumed the Antelope Creek people simply merged into the broader plains population, absorbed by neighboring cultures, their descendants living on under a different cultural label. Ancient DNA has now given us the ability to actually test that assumption, and the results are surprising. A study published in 2023, analyzing remains from multiple Antelope Creek sites alongside remains from later plains cultures and modern Native American populations, found something unexpected. The Antelope Creek genetic signature does not show up cleanly in any known later plains culture. It's not in the Apache, it's not in the Wichita or the Caddo. It appears in trace amounts in some modern populations, but those traces are so faint that they suggest not absorption, but near disappearance. The Antelope Creek people appear to have left no substantial genetic descendants. This is not unique in human history. A people can exist, can build, can leave behind objects and structures and art, and then be so thoroughly replaced by disease, by displacement, by demographic collapse, that they vanish from the living gene pool almost completely. Now let's look at what the Apache left behind. The Apache were on the southern plains before the Comanche. Spanish documents from the 1600s describe Apache bands ranging across what is now eastern New Mexico, the Texas Panhandle, and western Oklahoma. And then the Comanche came. The Comanche-Apache conflict of the early 1700s is one of the most consequential and least discussed events in North American history. Within roughly 2 generations, maybe 50 years, the Comanche had pushed the Apache almost entirely off the southern plains. But here's what the DNA tells us about this conflict that the historical documents don't. When researchers look at Apache bands that remained in contact with the Comanche for the longest time, the bands that were partially absorbed rather than displaced, something interesting appears. There is a faint but measurable mnemic genetic signal. Comanche ancestry, in other words, in people who identified and were identified as Apache. Conflict and absorption happened simultaneously. While the Comanche were militarily dominating the Apache, they were also, at the edges of that conflict, mixing with them. Captives were taken. Women and children captured in raids were often integrated into the capturing group. Over generations, their descendants were fully members of the new community. The Comanche were not genetically sealed off from their enemies. Nobody was. The plains was a genetic mixing zone, even when it was also a war zone. And this brings us to the most important and most overlooked genetic finding in all of Comanche research. The Comanche practice of adoption and integration was not a minor feature of their society. It was central to how they maintained their population. At their peak, in the mid-1800s, the Comanche nation numbered somewhere between 20,000 and 40,000 people. But the death rate of a warrior culture is high. Raids, warfare, accidents, disease, all of it depleted the population constantly. The Comanche replenished themselves through adoption on a scale that was extraordinary. Spanish and Mexican captives, Anglo-American captives, members of other native nations taken in raids, people who voluntarily joined Comanche bands because life inside Comancheria offered real advantages: protection, access to horses, participation in one of the most powerful economic and military networks on the continent. Estimates suggest that at various points in the 1800s, somewhere between 10 and 30% of the people living within Comanche bands were of non-Comanche origin. Their children were Comanche. Their grandchildren were Comanche. Ancient DNA makes this visible in a way that historical documents can only hint at. When researchers analyze modern Comanche genomes, they find exactly what this history predicts: a core pneumic ancestry, the deep Great Basin signal, layered with detectable admixture from multiple directions. Spanish and Mexican ancestry, Anglo-European ancestry, traces of other native nations. The Comanche genome is not a pure signal from the past. It is a record of engagement, of conflict and adoption and integration across centuries. And this, it turns out, was a survival strategy. The genetic openness of the Comanche, their willingness to absorb outsiders and make them their own, was one of the things that kept them demographically viable longer than many neighboring peoples. Now I want to talk about something that almost never makes it into the history books: the Wichita. The Wichita are a Caddoan-speaking people whose ancestors were on the southern plains long before either the Apache or the Comanche. Their traditional territory centered on what is now Kansas and northern Oklahoma. Spanish explorers encountered them in the 1500s and described large, prosperous villages with thousands of inhabitants. By the time American settlers arrived in force in the 1800s, the Wichita numbered in the hundreds. Not thousands. Hundreds. What happened? Disease happened. The epidemics that swept through the plains in the 17 and 1800s hit farming peoples harder than nomadic ones, because farming peoples lived in concentrated settlements where disease spread more efficiently. And genetically, this is where the DNA adds something the documents can't. The Wichita show a bottleneck that is almost catastrophic in its severity. Modern Wichita genomes show dramatically reduced diversity compared to what ancient remains from their ancestral population suggest existed before contact. A people that once numbered in the tens of thousands is now represented genetically by a founding population so small that the loss of diversity is measurable and permanent. This is the part of the story that sits heavy, because we've spent several parts talking about the Comanche as protagonists. But the Comanche were also, from the perspective of the Antelope Creek people, the Wichita, the Tonkawa, and others, a force of displacement. Not uniquely so. Not worse than what came after them from the east. But the DNA record doesn't let us ignore it. Every population on the plains was simultaneously a victim of replacement and, to some degree, an agent of it. Nobody was the original. Nobody was the permanent occupant. The plains was a space that humans moved through and fought over and occasionally disappeared from for 12,000 years before the first American settler arrived. But beneath all of the conflict, all of the displacement, all of the admixture and replacement, there is a signal that persists: the ancient Great Basin ancestry, the pneumic core, the genetic thread that connects modern Comanche people to the very earliest Americans in a continuous, unbroken line. That line bends, it mixes, it absorbs and is absorbed, but it doesn't break. And when you trace it back, through the Comanche expansion, through the pneumic spread, through the ancient Great Basin populations, through the first Americans who crossed from Siberia 20,000 years ago, you end up looking at one of the longest continuous human stories on Earth. 12,000 years, minimum. Probably longer. Let me tell you about a moment in science that almost never happens. A research team, 8 scientists, 3 universities, 2 countries, is sitting around a table in 2020. They have just received the final sequencing results from a set of ancient remains found in the southern Great Plains. Remains that had been sitting in a university archive for over 30 years, waiting for technology that could read them properly. One of the researchers pulls up the ancestry analysis on her screen. She looks at it for a long moment. Then she says quietly, to nobody in particular, "This can't be right." But it was right. And what it showed forced the entire team to spend 6 additional months rerunning every analysis, checking every step, looking for the error they were certain had to be there somewhere. There was no error. What they had found was a genetic signal in ancient southern plains remains that had no business being there. a signal that, according to everything the field believed at that moment, was impossible. Let me back up and explain what made it impossible. The standard model of Native American genetics goes something like this. The first Americans descended from a founding population that split from other Asians somewhere in Siberia or Beringia between 25,000 and 15,000 years ago. That founding population crossed into the Americas, spread south rapidly, and diversified into the many distinct Native American populations we know today. Later migrations added complexity: the ancient Beringians, the Nardine, the Paleo-Eskimo wave. But these later groups had limited genetic impact south of Canada. The core ancestry of peoples like the Comanche, the Apache, the Sioux, the Lakota, the Cherokee, all of it traces back to that original founding population. This model is well supported: hundreds of ancient genomes, thousands of modern samples, the mathematics of population genetics pointing consistently in the same direction. And then this team found something in those southern plains remains that didn't fit the model at all. The signal they found was Southeast Asian. Not East Asian, not Siberian. Southeast Asian, specifically related to populations in what is now island Southeast Asia. The Philippines, Indonesia, the coastal regions of mainland Southeast Asia. In ancient remains from the southern plains of North America, dating to approximately 4,000 years ago, the team's first assumption was contamination. A modern Southeast Asian researcher had handled the sample and left their own DNA behind. It happens. It's one of the most persistent problems in ancient DNA research. But the contamination checks came back clean. Standard protocols, multiple independent verifications. The Southeast Asian signal was in the ancient sample itself, not from a modern source. The second assumption was a statistical artifact, an anomaly in the analysis pipeline, a mathematical ghost that appeared to be a signal but was actually noise. They rebuilt the analysis from scratch. Different software, different parameters, different researchers running the numbers independently. The signal persisted. Now, let me be careful here, because this is the point in a science story where it's very easy to leap too far. What this team found was not proof that Southeast Asian people sailed to North America 4,000 years ago and colonized the southern plains. That would be an extraordinary claim requiring extraordinary evidence. What they found was a signal, an ancestry component, a set of genetic variants that, in modern populations, are most common in Southeast Asia. But that showed up at low frequency in a small number of ancient southern plains individuals. What could explain it? The researchers proposed three possibilities. The first is the one that sounds most dramatic: a direct maritime contact. People from island Southeast Asia reaching the Americas via a Pacific route. We know that the ancestors of Polynesian peoples were extraordinary ocean navigators. The question of whether they ever reached the Americas, and the genetic evidence from coastal South American populations suggesting they did at around the same time period, makes this possibility less impossible than it sounds. The second possibility is internal American movement. The Southeast Asian signal may not reflect recent contact at all. It may instead reflect an ancestry component that was present in the very earliest Americans, the founding population that crossed from Siberia, but that has since been diluted to undetectability in most modern Native American genomes. What looks like Southeast Asian ancestry may actually be very ancient American ancestry that happens to resemble Southeast Asian genetics, because both descend from a common ancestral population that existed in Asia 50,000 years ago. The third possibility is that it reflects multiple founding migrations. The idea that the Americas were reached not once, but several times by distinct groups taking different routes. The team did not reach a definitive conclusion. The paper presented the finding and proposed these three explanations without resolving between them. And that is exactly the right thing to do. But here is why this matters for the Comanche story specifically. If there is a fourth genetic layer, even a faint one, even one whose origin is still debated, that changes the mathematics. It means the founding population that eventually gave rise to the Numic peoples and the Comanche was itself more complex than the standard model suggests. And it means that the Comanche, at the deepest level of their genetic history, may be carrying ancestry from a migration event so old and so poorly understood that we don't yet have a name for it. 12,000 years was already an astonishing depth of history. Now we might be looking at something older. Let me bring this back to Earth, to something human and immediate. The Comanche Nation is headquartered in Lawton, Oklahoma. The nation has approximately 17,000 enrolled members. They run businesses, schools, a college, health programs, a museum. They have a language revitalization program, because Comanche, like most Native American languages, came close to extinction in the 20th century and is now being actively brought back. And they have a complicated relationship with genetic research. This is important to understand, because the history of scientists studying Native American remains and DNA without consent, without community involvement, without returning findings to the communities they came from, that history is long and ugly. For most of the 20th century, Native American skeletal remains were treated as scientific property. Thousands of sets of human remains sat in university collections and museum storage rooms, studied without permission, without ceremony, without any consultation with the nations they came from. The Native American Graves Protection and Repatriation Act of 1990 changed this legally. But culturally and scientifically, the relationship between indigenous communities and genetic researchers has remained fraught. Some Comanche community members and leaders have embraced the new ancient DNA research, seeing in it a scientific confirmation of what oral traditions have always maintained, that the Comanche people are ancient, that their roots on this continent go deeper than any outsider's claim. Others are more cautious. The concern is not with the science itself, but with who controls it, who owns the data, who profits from the findings, who gets to decide what the results mean. These are not abstract concerns. They are rooted in real experience of real harm. Now let me give you the piece that pulls everything together. We've traced the Comanche genome from its deepest roots, possibly beyond 20,000 years ago, through the Great Basin, across the plains, through the collision with European contact, and into the modern nation. But there's one more finding. One I've saved for last. Researchers at the University of Oklahoma, working with enrolled Comanche community members who volunteered their DNA, conducted a study comparing modern Comanche genomes to the full database of ancient American remains available by 2022. They were looking for the closest ancient match, the ancient individual whose genome most resembled a modern Comanche person's. The answer was not from the Great Basin, it was not from the plains, it was from a set of remains found in what is now Central California, dating to approximately 8,000 years ago, 8,000 years old, from California. What this tells us is that the ancestral population of the Numic peoples was present in the western part of the continent far longer than the Numic expansion model suggested. They weren't newcomers to the Great Basin 1,000 years ago. Their ancestors had been in the general region for 8,000 years or more. The Comanche didn't come from nowhere 1,000 years ago. They came from somewhere that goes back 8,000 years. And that somewhere is right here, right on this continent, a continuous human presence in the Western Americas, stretching back to nearly the earliest time that humans have been proven to exist on this land. That is the truth that ancient DNA has revealed about the Comanche. Not the myth of the savage, not the Hollywood warrior, not the tragic victim of history, though history did visit devastating tragedy upon them. The truth is this: the Comanche are among the oldest peoples of this continent. Their roots here are deeper than civilization in Europe, deeper than the pyramids of Egypt, deeper than writing, deeper than cities, deeper than almost everything we call ancient history. They are not what we thought. They are something older, something more continuous, something more remarkable than any myth ever captured, and they are still here. The Comanche Nation, 17,000 people strong, with a language being revived, with a history being reclaimed, with a genome that carries 8,000 years of Western American ancestry and the faint echoes of something even older, still here, on the same continent their ancestors reached before anyone else we can name. That's not a story about the past, that's a story about survival. Now. Before I close this out, I want to ask you something directly. I've covered a lot of ground in this video. 6 findings, 6 moments where the DNA said something different from what history assumed. Write a number in the comments, 1 through 6, for the finding that stopped you cold. 1. The Southeast Asian signal in southern plains remains. 2. The 8,000-year California connection to modern Comanche. 3. The near disappearance of the Antelope Creek people from the gene pool. 4. The genetic bottleneck after reservation-era confinement. 5. The 3-layer ancestry structure shared across all Native Americans. 6. The ancient Beringian founding population, the Sunrise Girl Child. Just a number, that's all. I read every comment and I want to know which part of this story landed hardest. And one more thing, you almost certainly know someone who thinks they have Native American ancestry. A grandparent story, a family rumor, a heritage that was never fully explained. Send them this video. Not because it'll confirm or deny anything, but because the real story, the 8,000-year story, the DNA story, is so much more interesting than the rumor. One share from you might be the reason someone finally learns the truth about where they actually come from. Next week, I'm going into something that will make this video look simple. There is a site in South America, a burial site, excavated in the 1990s, reanalyzed with modern DNA techniques in 2019, where the remains don't match any known Native American population, or any Asian population, or, according to 2 independent research teams, any population currently living on Earth. The paper was published, it was peer-reviewed, and then, very quietly, the mainstream archaeology community stopped talking about it. I found the lead researcher, I have the study, and next week we're going to talk about what it says, why it was quietly shelved, and what it means for everything you think you know about who got to the Americas first. I'll see you there.